All right, welcome back, everyone. Today we're learning about something called theoretical probability. Theoretical probability is the probability of what we expect will happen. Okay. So that means the game or the spinner or the game, the cards or the dice haven't been rolled yet, and this is what we expect will happen. So today what we'll do is we'll learn how to determine the theoretical probability of an event, and you'll ask yourself whether theoretical probability is like a guess, a guarantee, or is it like neither. So be thinking about that throughout the lesson. The do now you're going to read and do by yourself. So I'm going to say that this is an on your own. The early finisher you don't need to do unless you are an early finisher. And then you can turn the page over and continue. So to determine the theoretical probability, it says that Archie plays a word board game. He places 98 letter tiles and 2 blank tiles in a bag. Players will draw tiles from the bag one at a time without looking. What is the probability that the first tile drawn will be a blank tile, labeled with labeled with a letter, a vowel, or a consonant? So these are already done for us. So the probability of getting a blank tile is 2 out of 100 because there's 2 blank tiles and there's 100 tiles total, and then that simplifies to 1 over 50. Labeled with a letter, the other 98 tiles are labeled with a letter, so that's 90, which simplifies to 49 over 50. Talk about how many are labeled with a vowel. So you count up how many are labeled with vowels. So A, E, I, O, U. So A, E, I, O. You count those up. Get 42. 42 over 100, it simplifies to 21 over 50. And then how many have a consonant on it? That would be the rest of the 98, so that would be 56. So a consonant is all of the letters that are not vowels. So starting here with B, all of these, we get 56. So 56 out of 100 is 28 over 50. So you're going to go and do this question on your own. You're finding the theoretical probability getting a number greater than 2. Here you're going to find which of these statements are true, and you're going to do that on your own. Next, it says, Talia and Yoshi design a game for their school fair. Contestants spin the spinner and win a prize if it lands on either of the 2 red sections. So these are the red sections here. How can Talia and Yoshi determine how many people are likely to be winners if 500 people play their game? So first we're going to determine the total number of possible outcomes from one spin on the spinner. There are 16 sections that are all the same size, and there are 2 sections of each color. So the pointer could land on any of the 16 sections, so there are 16 equally likely outcomes. Because we know all the possible outcomes, we can find the theoretical probability of an event, such as the pointer landing on red. E represents theoretical probability. An event, single outcome, or a group of outcomes. So this is the probability of a certain event happening. It's the number of favorable outcomes compared to the number of total outcomes. So if we talk about landing on a red, the probability of landing on red, 2, the number of total sections is 16, and so that simplifies to 1/8. To change a fraction into a percent, you do the numerator times 100. So you do 12.5%. Here's what we do, is we are going to write a proportion, because remember, we have to find out how many winners they think there will be if 500 people play their game. So what we do is we take probability of someone winning, which is 1/8, and we make a proportion using 500 as the total. So 500 gets placed here with the 8 because it's the total, and we're trying to find out how many winners there are. When we have an equation that uses division, we multiply by the denominator on both sides. So on your calculator, you type 1 times 500, 8. So you do 1 times 500, and then divided by 8 to get 62.5. So then we can say that they are likely to have about 62 winners, 62 or 63 winners, based on the theoretical probability. That's what you'll be doing for the rest of the lesson. So I'm going to do a few more examples with you so that you can get used to writing and solving a proportion, because it's been a while since we've done that. A 12-sided solid has faces numbered 1 through 12. Find the probability of rolling a number greater than 5. So we have 1, 2, 3, 4. Finding the probability of rolling a number greater than 5. This seems familiar because I think we did this during our last lesson. So there should be 7. So there are 7 out of 12. If it's rolled 180 times, how many times would you expect it to either land on a 3, a 9, or an 11? So there's 1 3, 1 9. So there would be 3 out of 12. We rolled 180 times, then 180 goes here across from the 12. And then we multiply by 180. So on your calculator, you're going to type 180 times 3 divided by 12. So 180 times 3 divided by 12 to get 45. Based on statistics for the past several seasons, the probability that the best player on a basketball team makes a free throw is 8 out of 10. The probability that the second best player makes a free throw is 13 out of 20. If both players attempt 143 free throws over a season, how many sorry about that. If both players attempt 140 free throws over a season, how many more free throws is the best player expected to make? All right, and I'm going to underline this part here where it says how many more free throws, because that's something I'm going to forget to do later. So I've got the probability of 8 over 10. It's 140. So I put that here with the total. So I multiply by 140. So I do 140 times 8 divided by 10. So that's 112. And then we have 13 out of 20. It's x over 140. So we multiply by 140 again. Times 13 divided by 20. E1. To remember my answer, I have to subtract these to see how many more. So we get 21. Last one I'll do with you is here. So it says the spinner at the right is divided into 8 equal sections. Find the theoretical probability described below. Write your answer as a simplified fraction. So what's the probability that you get a number that's less than 6? So less than 6, so I've got 8 sections total. Less than 6 is 1, 2, 3, 4, 5. So that would be 5 out of 8. And if we're looking for how many times, if it's spun 30 times, we'll land on a number less than 6. We take 5/8. X over 30. We multiply by 30 on both sides. For calculator, you do 30 times 5 divided by 8. It's 5 divided by 8. So for the rest of the problems, you're going to be doing a lot of this, okay? So for the rest of the problems, you're going to be writing your probability ratio, multiply on both sides by the denominator. So you're going to do that for the following questions. So this is an on your own right here for Samira. This is an on your own. This is an on your own question. And then on the back, two are on your own as well. Started with our work.